Hi, welcome to Linear Model with me again, Karini Abdullah. For this session, we will learn about multiple model. Here is the outline of what we will discuss for this session. First, we will look at the general form of the linear model. Then we look at the form of each type of the covariates. They are numerical covariates, categorical covariates, and then we will look at the model with mixed covariates. So, while in simple model, we have the form of the model is just like this, where y is explained by just one predictor variable, that is x. In multiple model, instead of having one, we have several covariates. Let's say we have x1, x2, x3, all the way to the xp. So the form of the model is like this, where actually it looks similar with a simple model, except that in a multiple model we have p predictors instead of instead of one predictor variable. The assumptions about the error term is exactly the same like in the simple model, that is normally identically independent distributed with a mean of 0 and the variance of sigma squared. Now we look at the model with numerical predictor variables. For the first order model, this is the general form of the model, that is expected value of y uh, is given by beta naught, the intercept, plus beta 1 x1 all the way to beta p xp, if we know that we have p predictor variables to be included in the model. While for the second order model, let's say we have just, to make it simple, we have two predictor variables. Then the second order model can take the form like this. So we have additional information or additional term on beta 3 x1 x2. And a complete second order model, again, this is just an example using two predictor variables. In addition to x1, x2 and interaction between x1 and x2, we also include that the squared form of x1 squared and x2 squared to be the fourth and the fifth terms explaining y in the model. So, the first order model is also known as the main effects model. The second order model, where it contains the multiplication between predictors. In here, it is called the interaction term, and this is the interaction between x1 and x2. Now let's have a look at how to do the interpretation on the contribution of each predictors in multiple linear model. Let's look at the first order model here. To do the interpretation, let's say we want to see the contribution of x1 in explaining y. Then we try to substitute a certain value of x1. Let's say here we take the value of x1 equals a, where a can be any number. Then we substitute it into the equation, so we have something like this. And because we want to see the contribution of x1 in explaining y, it means that what is the changes in y when we change the value of x1. And because we want to assess the effect of changing x1 to y, it means that all other variables need to keep constant. So here we only change the value of x1 from a into a plus 1 while keeping all other variables constant. So here are the two equations, and then we look at how much is the change in expected value of y. So we can just cross out all other things here because all x's are the same. So we cross them out. So we have the result in change of y is just beta 1. So from this calculation, we can make a conclusion that beta 1 is the average change in y for a unit change in x1, because here we just change x1 from a to a plus 1. So 1 unit change in x1, keeping all other covariates constant. Similar interpretation can be given for beta 2, beta 3, all the way to beta p. So let's say beta 3. So beta 3 means the average change in y for a unit change in x3, keeping all other covariates constant. Now we look at the interpretation if we have an interaction term in our model. So this is an example of just using two covariates. Again, let's see the role of x1. So we set up x1 equals a, and we get and we substitute it into the model. We have something like this. So all x1 change it into a. So that's why we have this expression. And now we change x1 into a plus 1. So we increase it by 1 unit, and we get this result. And again, this is just a simple math procedure. We calculate the difference in y, so that beta naught cross out, beta y a cross out, all other things are crossed out. What's left is beta 1 here, plus here we have beta 3 times 1 times x2. So in here we can see that the change of y when we increase x1 by 1 unit is not a constant, not only beta 1 or beta 1 plus beta 3, but it depends on the value of x2. That's because here we have the interaction term here. So in this example, we can conclude that the effect of changing the value of one covariate to the target depends on the value of the other covariates. So with similar procedure, we also can show that the effect of changing x2, for example, by 1 unit is also not just beta 1, but it should be not just beta 2, but it should be beta 2 plus beta 3 x1. So in this case, we cannot just do interpretation of beta 1 separately or beta 2 separately, because there is an interaction between x1 and x2. So their effect to the value of y depends on the value of the other covariates. So in the quadratic models, we have, in addition to the interaction, we also include the quadratic terms of x1 and x2. The question is that we have similar issues with the interaction model. Like in interaction model, we cannot do interpretation of beta 1 or beta 2 separately, because the effects are the effect depends on the other value. The effect of one variable depends on the value of the other variables. So it just makes sense that similar problem questions arise for the quadratic term. So here we have the question that can we interpret beta 4? Can we interpret beta 5? And how to measure the effect of x1 on y, and the same how to measure the effect of x2 on y. To answer this question, you just need to do like substitution, like what has been demonstrated before. You pick one value for x1, you increase it by 1 unit, and then you do just a little bit of a mathematical procedure to see whether you can do interpretation on the beta separately, and whether you can do the measure the effect of x1 on y, whether it depends on x2 or not. So this is kind of like your homework to do this one. So for this session, we have this conclusion that for the first order model, beta j measures the average change in y for one unit change in x1. For one unit change in xg, keeping all other covariates constant, while for the second or higher order model, the partial effect of a covariate on y depends on the value of the other covariates.